Well, student, today is the next example of chapter number 1. That example number it is 1.9. Now, this example it is related to the electric dipole. What is equation of electric dipole? So that is Q into 2A. What is equation of dipole moment? That is Q into 2A. And the total charge on the dipole it is 0. Now, the question of this example number 9 it is to be like this. That question is a system of two charges QA is equal to 2.5 into 10 raised to minus 7 coulomb and QB is equal to minus 2.5 into 10 raised to minus 7 coulomb located at a point A 0 minus 15 centimeter and at point B 0 plus 15 centimeter respectively. What is the total charge and the electric dipole moment of the system? What is the total charge and the electric dipole moment of the system? So on this example, it is related to electric dipole. The total charge on the dipole is always 0. And calculate the dipole moment, that is P is equal to Q into 2A. Okay? Your student charge QA is equal to 2.5 into 10 raised to minus 7 coulomb. QB is equal to minus 2.5 into 10 raised to minus 7 coulomb. These two are the equal and opposite charges. Their magnitude are same, but they are the opposite charges. Okay? QA charge is placed on the z-axis. It is placed on the which axis? Z-axis. QB also placed on the z-axis. So when the position of the QA charge it is 0 minus 15 centimeter. Position of the QB charge it is 0 plus 15 centimeter. This is your x-axis. This is your y, and this is your z. Dipole is lying above the which axis? Z-axis. Calculate the total charge on the dipole. The total charge on the dipole, that is QA plus QB. Well, QA is equal to plus 2.5 10 raised to minus 7. QB is minus 2.5 into 10 raised to minus 7. Total charge on the dipole is 0. Now, to calculate the electric dipole moment, we require a distance between the two poles. So, this much distance is plus 15 and this much distance is minus 15. Total distance between these two poles, it is 15 plus 15, 30 centimeter. So, this we can say the distance between the two poles denoted by 2A. That 2A is 30 centimeter. Convert the centimeter into meter divided by 100, 0.3 meter. So the dipole moment can be given by small p is equal to QA into 2A. Why we are taking this QA? Because we are taking the magnitude of charges. Magnitude of either of charges. So that we can use the QA and we can also use the QB. In short, we are taking the magnitude. Therefore, negative becomes positive. Like QA into 2A. Well, QA is 2.5 into 10 raised to minus 7. 2A is 0.3. By multiplying them, your answer will be coming 7.5 into 10 raised to minus 8 coulomb into meter. Dipole moment it is a vector quantity, and the direction of the dipole moment it is from the negative charge to the positive charge. So this is your negative charge, this is your positive charge. Therefore, direction of the dipole moment it is from B to the A. It is to be acting in which direction? Negative z direction. Therefore, dipole moment acts in the direction of the B to A, that is along negative z-axis. That is along the negative z-axis. Okay? So now example number 1.9 it is completed. Now we are moving to the next example. That is your example number 1.10. Now the question of this example number 1.10 it is to be like this. So this example it is to be solved by using the equation of torque. What is equation of torque now? It is vector P cross vector E. And the expansion is P sin theta. Simple example is there. Now the question of this example number 10 it is like this. An electric dipole moment 4 into 10 raised to minus 9 coulomb into meter is aligned at 30 degree with the direction of uniform electric field of magnitude 5 into 10 raised to 4 Newton per coulomb. Calculate the magnitude of torque acting on the dipole. Calculate the magnitude of torque acting on the dipole. So, this example in which dipole is placed in a uniform electric field so that it is just experience the word torque, but the resultant force is what 0. So that dipole moment P is equal to 4 into 10 raised to minus 9 coulomb into meter, angle theta 30, electric field is 5 into 10 raised to 4 Newton per coulomb. What is equation of torque? Tau is equal to P sin theta. All values are given. Well, P is equal to 4 into 10 raised to minus 9. E is equal to 5 into 10 raised to 4. Theta is equal to 30. Sin 30 is equal to 1 by 2. So that you can get the answer 10 raised to minus 4 Newton into meter. It is very simple example. This example it is to be asked in 1 marks, not in 3 marks. Okay, this example is completed. Well, student, now we are moving on to the next example. That is your example number 11. Example number 11. In this example number 11, we are calculating the actually the number of charged particle, and we calculate the change in mass. In short, this example it is related to the transfer of the electron from one body to the other body, and also we can calculate the change in mass. Okay. So now the question of this example number 11, it is to be like this. The question of this example number 11, it is to be like this. A polythene piece rubbed with the wool. Polythene means plastic. This rubbed with the word wool. Is found to have a negative charge 3.2 into 10 to minus 7 coulomb. Means what? Polythene rubbed with the wool. Then polythene becomes a negative charge and the wool becomes a which charge? Positive charge. Then it is to be found that it is have a negative charge. It is have a negative charge of 3.2 to 10 to minus 7 coulomb. Estimate the number of electron transferred. Second question. Is there a transfer of mass from the wool to polythene? Is there a transfer of mass from wool to the polythene? There are two questions. Estimate the number of electron transferred and estimate the change in mass. So well, charge Q is equal to 3 into 10 to minus 7 coulomb. Charge on each electron is 1.6 into 10 to minus 19 coulomb. Example can be solved by using the equation of quantization. So then what is equation of quantization? Q is equal to N. What do we require? Number of electron transferred. Make a subject of N. So then write down Q by E. Well, capital Q is equal to 3 into 10 to minus 7 and E is equal to 1.6 into 10 to minus 19. So that number of electrons are transferred from the one body to the other body. It is 1.87 into 10 to 12. Okay, the first question is completed. Now we require the second question. Answer of the second question. Yes, there is a transfer of mass from wool to the polythene because electron has finite mass. Mass of one electron, it is 9.1 into 10 to minus 31 kilogram. This much number of electrons are transferred so that change in mass can be calculated N into N, where N is equal to 1.87 10 to 12, mass of electron 9.1 into 10 to minus 31. By calculating them, your answer will be 1.7 into 10 to minus 18 kilogram. This much mass it is going to be transferred from wool to polythene because the electrons are deposited on the polythene. Mass of the polythene increase, mass of the wool is decreases because the wool is loses the electron. Okay. Now this example number 11 also completed. Now we are moving on to the next example. That is your example number 12. And the question of the example number 12 is like this. Two insulated charged copper spheres A and B have their centers separated by a distance of 50 cm. What is the mutual force of electrostatic repulsion if the charge on the each is 6.5 to 10 to minus 7 coulomb? The radii of A and B are negligible compared to the distance of separation. What is the force of repulsion if each sphere is charged double the above amount and the distance between them is half? Well, student, there are two spheres are given. Name of that sphere it is A and B. Charge on the both sphere is same. Therefore, QA is equal to QB is equal to 6.5 into 10 to minus 7 coulomb. Distance between them is 50 centimeter. Convert into meter, 0.5 meter. Both are the like charges. Between them, repulsive force is acting. So that force of repulsion between the two spheres can be calculated using this equation. F is equal to K QA QB by R square. Now simple substitute their values. What is value of K? 9 into 10 to 9. Q and QB both are same value, 6.5 10 to minus 7 whole square, and distance between them is 0.5 square. So that by calculating them, your answer will be 1.52 into 10 to minus 2 Newton. Now the answer of the first question is completed. Now this second question. Charge on the each sphere is double and separation it is what half. Now make it double charge on the each sphere, separation is what half. Okay, now the charge on the both sphere is double and the distance is what half. So that this equation now rewrite it. QA replaced by 2QA, QB replaced by 2QB, and the distance are replaced by R by 2 because charges are double and distance is half. So that 2 into 2 4, 4 into 4 it is 16 k qa qb by r square. What is the answer of k qa qb by r square? It is this one, 1.52 to 10 raised to minus 2. 16 as it is. By calculating them, your answer will be coming 0.243 Newton. 0.243 Newton. Okay? Now this example number 12, it is also completed. Now we are moving on the next example. That is your example number 13. Student, in this example number 13, it is related to the charging by the physical contact. It is related to the charging by physical contact and calculate the value of the force from the Coulomb's law. Now the question of the example number 13, it is like this. Question of the example number 13 is like this. Suppose the spheres A and B in exercise 1.12 have the identical size. A third sphere of the same size but uncharged is brought in contact with the first, then brought in contact with the second, and finally removed from the both. What is the new force of repulsion between the A and B? What is the new force of repulsion between the A and B? Okay? Student, charge on the each sphere from the previous example, that is Q is equal to 6.5 to 10 raised to minus 7 coulomb. Separation between them is 0.5 meter. Student, in the first case, sphere A, it is brought in contact with the another identical sphere C. Then sphere C, it is brought in contact with the sphere B. That means what? Sphere A brought in contact with the sphere C. Then sphere C brought in contact with the sphere B. Instead sphere C make a contact with the sphere A and with the sphere B. It makes a contact two times. Okay. First, when a similar but uncharged sphere C is placed in contact with the sphere A, each sphere shares a charge Q by 2 equally. Because the charge on the sphere A, it is Q. Charge on the sphere C is 0. Now make them in contact, brought them in contact. So that Q plus 0 by 2. So each sphere has a charge Q by 2, Q by 2. Now the charge will be what said? Equally distribution will be takes place. So the sphere A and sphere C has a charge Q by 2, Q by 2. Now student, now sphere C placed in contact with sphere B. This sphere C has a charge Q by 2 and sphere B already has a charge Q. Make them in contact and separate them. So the charge on the each sphere B comes, that can be calculated using this equation Q plus Q by 2 divided by number of spheres. By calculating them, your answer will be coming 3Q by 4. So that sphere B has a charge 3Q by 4 and sphere C has a charge 3Q by 4. Distribution of the charge will be equal because both are identical spheres. Both are in the same size. Now student, sphere A has charge Q by 2. Sphere B has a charge 3Q by 4. Separation is same. Calculate the force acting between them. So that F is equal to K, Q by 2 into 3Q by 4 by R square. Student, this is 3 by 8. It is outside. KQ square by R square. 3 by 8 is it is. What is value of K? 9 into 10 raised to 9. What is value of charge Q? 6.5 into 10 raised to minus 7 whole square. And distance R is 0.5 whole square. By calculating them, your answer will be coming 5.7 into 10 raised to minus 3 Newton. Okay? So now this example number 13, it is related to the charging by the which contact? Physical contact. It is completed. Now we are moving on to the next example. That is your example number 15. It is your example number 15. Where student, this example number 15, it is related to the equation of electric flux. Electric flux phi is equal to vector E dot vector S, or you can use E S cos theta. Okay, very simple example. Now the question of the example number 15, it is to be like this. Consider a uniform electric field E is equal to 3 into 10 raised to 3 I cap Newton per coulomb. It is shows that electric field it is present only in x direction. What is the flux of this field through a square of 10 cm on the side whose plane is parallel to the yz plane? Second question, what is the flux to the same square if the normal to its plane makes an angle 60 degree with the x-axis? Okay, so there are two questions. First things, vector E is equal to 3 into 10 raised to 3 I cap Newton per coulomb. Length of the each side is 10 cm. Convert into meter, let me skip 0.1 meter. So this value shows that electric field exists only in x direction. According to your question, the plane is lying in a YZ plane. That plane is lying in a YZ axis, parallel to the YZ axis. So the area vector of this plane, it is normal to the plane. So that vector E, vector S, both are in which direction? Same direction. So that we can calculate the electric flux. Angle between them is 0. Angle between them is what? 0. Area of the square S is equal to L square. 0.1 square. 0.1 square is 0.01 meter square. Angle between E and vector S is 0. So that flux phi is equal to ES cos theta. Theta is equal to 30. Theta is equal to 0 degree. Value of E 3 into 10 raised to 3. S is equal to 0.01. By calculating them, cos 0 is equal to 1. By calculating them, your answer will become in 30 Newton meter square per coulomb. Okay, first question completed. Now in the second question, what changes takes place? Only angle is changed. Only angle is changed. Angle becomes 60 degree. Angle becomes 60 degree. So the theta is 60. Same equation can be used. Flux phi is equal to ES cos 60. E is equal to 3 into 10 raised to 3. S is equal to 0.01 cos 61 by 2. So that answer is 15 Newton meter square per coulomb. It is very simple. Okay. Now this example also completed. Only one equation can be used. Flux phi is equal to ES cos theta. Okay. Now we are moving on to the next example. That is your example number 17. This example number 17 can be solved by using the Gauss equation. Flux phi is equal to Q by epsilon 0. This equation simple can be used. Now the question of the example number 17 is like this. Careful measurement of the electric field at the surface of a black box indicates the net outward flux through the surface of the box is 8 into 10 raised to 3 Newton into meter square per coulomb. First question, what is the net charge inside the box? Second question, if the net outward flux through the surface of the box were 0, could you conclude that there were no charge inside the box? Why or why not? Okay. Let's run the value of the flux is given. That flux phi is equal to 8 into 10 raised to 3 Newton meter square per coulomb. First question, how much electric charge it is engrossed by the box? That can be calculated using the Gauss equation. What is our Gauss equation? Phi is equal to Q by epsilon 0. So that the net charge Q is equal to phi into epsilon 0. What is value of phi? 8 into 10 raised to 3. What is value of epsilon 0? 8.854 into 10 raised to minus 12. By calculating them, this multiplier 70.8 into 10 raised to minus 9. 3 minus 12 minus 9. And now displace the decimal towards the left side. That is 0.07 into 10 raised to minus 6. So that answer is charge Q is equal to 0.07 microcoulomb. This much amount of the charge it is enclosed by the box. Now there is an answer of the second question. No, we cannot say that there are no charges at all inside the box. We cannot say that there are no charges at all inside the box. We can only say that the net charge inside the box is 0. Because maybe the number of positive charges and number of negative charges are same, therefore the net charge is 0. So that we cannot say that the box it is not having a charge. If it is a positive charge, number of positive charges and negative charges are same, then net charge is 0. But total charge, the net charge is 0. But we cannot say that the box is not having a charge. Okay? Now this example is also completed.